Ladies and gentlemen, I'm very glad to be here with you, and I appreciate the invitation from the many organizers, and I just try to talk about some the proposed, not so much how can I say, sophisticated. I propose to Professor Novak our method might be usable to obtain some logic, the rules for your method in future. This was the proposed the 1984 or 5. Quite old method, but still we are brushing the method up. So my talk is the concept and the progress of fuzzy regression analysis. Of course, not only fuzzy regression, for example, the rough set might be usable to obtain some rules, like association rules, from the data. It is quite how can I say? It is quite the convenient and easy way. And the granular concept is also very important to clusterize or the obtaining rules from the data, because all the data is numerical values, but human cannot consider each concrete values. We have to have some linguistic words. So each word and the value is not a linguistic word. So we have to acquisite some words from such many values. So the granular concept might be might play the important role again of obtaining the rules. So of course, as you know, regression is not concerned with this, but I try to use to acquisite some rules based on the regression analysis. So of course, it is not the perfect one. We can use this one for some portion of acquisition. Based on, for example, the Professor Novak's proposal, the theory. So of course, all people know the Professor Zade. Professor Zade proposed the fuzzy set 1965. So after then, the various method and concept are widely proposed. Not only fuzzy logic, but also fuzzy integral and so on and so forth. One of them is the fuzzy regression analysis. So this is a famous paper published in 1965. All people know. And when we consider real situation, but the real situation is not easy to deal with. For example, this is the all palm fruit. All palm fruit is used to obtain the gasoline, oil. But the quality of oil is depending on the quality of the fruit, of course. Then we have to select a good oil palm fruit. In Malaysia, the oil palm fruit is very much popular to produce. So they produce the oil from this fruit. So they check which fruit is good or poor by seeing. We cannot use the mechanical way. The image processing is not powerful today yet. So we check the color and the shape and detach and attach the fruitlet. So then we selected a good one to produce good oil. The poor one will produce lesser the quality oil. So we would like to automatizing this process. So I suppose the fuzzy method might be powerful to deal with such a problem. So this is some features to selection of oil palm fruit. So color and shape, the surface shape, they are quite important factors. When we select the orange, the sasimon, we check the color of these fruits. Then quite red is good, but still the blue, we hesitate to eat. Maybe it is not so sweet. So we can understand the content by the color of surface color of these fruits. So the attached fruit, detached surface, and the condition, maybe usable. But when we human evaluate them, we used to use the linguistic words instead of values. We do not use the color, how can I say, the color with numerical values and weight, just the heavy or large or like this. So as you know, I'm intending talking about regression. The statistical regression was proposed at the 1950s. It is Francis Galton. As you know, the solution can be obtained easily by numerical equation like this. So if we use coefficient, these are the vector matrices. This is matrix and vector data of independent variables. This consists of the 1 to n variables depending on the number of samples. So small y is the vector of data of dependent variable. It consists of n elements, and y is system values. We think the system provided some values. System itself is linear, but unfortunately, some errors or something they are added in the observation or some process. Then we have data like this. These data are not linear, but we have to find linear structure of the latent system. So this is a latent system. This is linear. So this is a supposed latent system. So if we calculate the error, evaluate the obtained value and the supposed latent system value, it can be expressed. If we write the latent system using the coefficient and the data, then it can be written like this. I did not explain the detail of the vector matrix. So quite easy to solve this problem. We can partial differentiate by A, then we can obtain the solution, numerical equation, and solve this problem easily. It is a statistical problem. But this is depending on the statistical concept, that is errors. We intend to remove errors and to find a latent linear structure. If we think these are expressing the system itself, like an economical system, all the value may be expressing the economical structure. Of course, we can employ the nonlinear structure, but it looks like linear. So if we would like to apply linear system, this is not linear, then we fail to complete our trial. But employing the fuzzy concept, we can take them as a possibility, expression of the latent system. So the latent system has some possibility of the latent system that we may express using fuzzy function. Fuzzy function has some interval. Then the nonlinear structure can be solved by linear function. So we explain this. So do you know these people? Of course, this is me, quite young. This was taken 1983, and in Taipei. In Taipei, we had a conference, IFAC. So this conference is quite important. Many scholars in fuzzy the research, including Professor Zade and Professor Taksen and so on and so forth, Professor Zimmerman. There are many people who are gathering from Japan and Europe and the United States. So this is Professor Tanaka. Unfortunately, he passed away this May. He is quite famous, and he proposed fuzzy regression and fuzzy mathematical programming, linear programming, as well as Professor Zimmerman. And he is Dr. Zommer. He obtained a degree under the Professor Zimmerman. And we gathered there. Yeah, this is a Grand Hotel in Taipei. We enjoyed the coffee, and I do not smoke today, but at that time I like that smoke. But today I stopped smoking. Then he proposed this paper, the linear regression analysis with the fuzzy model. So it is 1982. Suppose I don't know, suppose 92. But he presented this method around 1980s, the beginning of 1980s. So many papers are started from this paper about the fuzzy regression analysis. Today, many people are working on this research. So I would like to talk about shortly. I would like to talk shortly about fuzzy regression. So this is a concept of fuzzy regression. As I told you, we have data. These are not linear, but we can express these samples using linear function if we employ fuzzy numbers. So we think these values as a possibility. Even the same values have various results of y. But this value has some possibility. Then we may express using fuzzy number. Fuzzy number has an interval like this. So we try to model these samples using fuzzy linear function. So this is the upper line and the lower line. So we include all the samples using fuzzy linear function. So this is the upper line and the lower line of one fuzzy linear function. Right? So we would like to find this fuzzy linear function, one line. So this is the fuzzy number, the trapezoidal shape. The A is the center and the C is the widest. It is written like this, and the very popular expression. Sorry. So this, if we use the fuzzy number like this, so the y can be expressed ax like this, right? A is a coefficient. The vector have a center and widest, a kind of the matrix. So like this. So calculation is done like this. I do not explain the detail. If we use this one, we can express upper line and the lower line. Like this. Then the upper line is written like this, equal, right? So the lower line is written equals center value minus the widest. This is widest, right? Widest is the added some widest is expressing the upper line. If we remove the center value with the some widest, then we can obtain the lower line. Sorry. So all the samples should be included in the interval between upper value and lower value. So this is the constraint of our problem. So the widest should be positive. Then we have to solve this problem under these constraints. Then of course, if we see many solutions can be considerable. They are like this, but the rigid shape is better. Rigid means the narrow widest, right? So it can be written by linear programming problem like this. This is a linear program. Easily solvable, this problem. This is the proposal given by Professor Tanaka. So we are working on the concept. So but we think today's world, we have many problems, and it is not only numerical. Also, it is not only fuzzy values. We have to take the care of stochastic or random situation. So it is not easy to solve the linear situation only using fuzzy number, only using the probability. So we have to consider both fuzzy and the random situation. So we have to multiple the uncertainty we have to consider multiple uncertainty. So, for example, the measuring is numerical, but sometimes we evaluate them more roughly without 1 point something centimeter, or the smaller is much usable the expression linguistic word. So for example, when we recognize the human face, we do not measure how much length between two eyes. We do not evaluate the color with numerical values. We do not express the mouth shape. We just say the looks like the black color. Black is a linguistic word, and so on and so forth. The design is the same. We take this car as a sporty one. So we express such a concept using linguistic words again. So the natural logic, the fuzzy natural logic is powerful. But again, we have to provide some the acquisition method, like the rough set theory. There are several methods, but unfortunately, we do not have many good ways. So again, if we obtain some rules from them, from the expert evaluation, we have to provide such a method. So these expressions might be given using linguistic words. Not only linguistic words, but also these words are given with a probability. For example, when the object is evaluated by plural the experts, these experts are not always the same values. So it might be taken as a random variable, fuzzy linguistic random variable. So we may consider them. So we would like to start again from the explanation of fuzzy regression analysis. So this is the problem of the fuzzy regression analysis. As I told, the problem can be solvable using linear programming. It is quite easy way. Professor Tanaka proposed linear programming. It is the most important the aspect of the method. Like this, right? Then we can solve this one using this one. This is the first paper. After that, we published various papers, fuzzy sets and systems, and the European Journal of Operational Research, and so on. But again, we start from the beginning. When we have crisp numerical values, it is easy, as you know. As I explained, this problem can be solvable using linear programming. So these are numerical values. Then we can solve this one. This is the point. Right? This can be solvable using linear programming again. So we obtain minimum vagueness of the model. Then we can easily solve this the repeated explanation. But how about if we have fuzzy objective value? Is it easy to solve? Like this one. In this case, this value is the point. We do not have the interval. If we have interval values, how do you think? It's easy, of course, quite easy. We may put this interval under this line, above this line. So we may solve this interval using this constraint. Then oh no, I skip. Sorry. In this case, this problem is solved by the same approach easily, as you know. But next is the third question. So proposed several papers about these problems. And how about the x and y are fuzzy values, fuzzy numbers. This one fuzzy, and this one also fuzzy. As you know, the product will be depending on the sign of the value. If we have a minus minus, then the calculation is possible. And also if we have a plus plus or minus plus, this can be calculatable. But if we do not know the sign of this, we cannot tell how to calculate. Is that clear? This product will be done like this, right? So the 8, 2 is the answer of this product. But if we have then this will be the same. But if we calculate how about this? In this case, we product like this, and so the minus x. The calculation is different depending on the signature, the sign of the value, right? In this case, minus 1, minus 1, but in this case, minus 3, product 4. The different way depending on the sign of numerical values. So, but unfortunately, we do not know the sign of this. We are looking for the calculating this value. So it is quite difficult. Of course, it is not difficult, but when I was given this problem from Professor Tanaka, I could not solve this. Then we employed the heuristic method. We wrote the paper in 1984 or 5. So it is quite usable, the powerful heuristic method. Even today we can use this to solve the problem easily. But theoretically, it can be solvable. Consider like this. We published this problem like this. So we can consider these problem like this. We may take this point like this. The fuzzy number consists of the vertical point. So we may include all vertical point within the two lines, right? Upper bound line. So they are easily solved. But when we have many coefficients and many samples, it might be quite huge constraints. The exponential, the number of constraints, it may be how can I say, not easy to calculate. So is it clear? We may write this problem like this. Sorry. I did not write the problem. Later we return this problem. So like this. So we can solve all the problems using fuzzy linear regression. I proposed the heuristic method to first calculate the result. Then we may return to linguistic value. What should we do to solve the verbal words, to obtain the linguistic regression model for linguistic terms? After obtaining the rules, we may apply the various logical method. So these words are not fuzzy linguistic terms, as shown like this. This was worked on in 1984 or 5. So we had the earthquake in San Francisco a few years previously. Then we worked to evaluate the building. So the parameter is like this. Corrosion state and the cracking state of walls or the floor. There was sail. So depending on these values, we evaluate the structure, the state, the total assessment, safe or not safe. The question was like this. So of course we have to consider used way, history of using this building or the circumstance, environment. If the road has a big track, then maybe running of a truck, the running of trucks influence on the architecture. So we consider them. But again, these are not the numerical value. If we have numerical values, we can apply the linguistic regression analysis. Then we have the linear function or non-linear function. Our problem is like this. So fortunately we know fuzzy control. Fuzzy control does not use linguistic words directly, but anyway, linguistic word is employed to apply the linguistic logical calculation. by fuzzy number. In order to apply logical operation, they translate linguistic word into fuzzy number. So we may employ this way. So we translate this word into fuzzy number using dictionary. So it is not possible to apply fuzzy regression to linguistic words directly. So these are the linguistic value. Also, these values are given with probability like this, right? So we may translate these values like this, using the dictionary. Later I showed these are value of expression these based on the dictionary. So we would like to explain a little bit more behind the theorem. So as you understood how to calculate linguistic regression analysis, we translate linguistic words into fuzzy numbers using a dictionary. Then we can build fuzzy regression. Later I explain a little bit more. So but our problem is we have the linguistic word or fuzzy numbers, but these values are given probabilistically. Then we should consider probability. So various scholars propose fuzzy random variables, but in this place we employ the Liu's method, credibility method. He defined the credibility like this, using the middle point between possibility and necessity. Possibility is the maximum value of the fuzzy membership grade, and this is 1 minus possibility. The necessity is defined by 1 minus possibility like this, but the credibility is defined the middle point between them. So for example, the numerical value, fuzzy number is given like this. Then we can calculate expected value of y. This is not a random fuzzy number. Fuzzy number is calculated like this, right? But when we are given random values like I did not expand. It can be calculable using credibility. So that means like this. We have probability distribution, but the value is not the crisp numerical value. The value is given fuzzy number like this. So it is named fuzzy random variable. So we calculate this depending on Liu's credibility. So using them, we can calculate even variance depending on credibility. So again, we may back to the same data. We have a value fuzzy number with probability like this. This value is calculated the mean and variance like this. So we built this model depending on fuzzy numbers with probability So these values are given randomly. So we calculate the mean values of this. This is a random sample, but using the credibility, we may calculate mean, and we can calculate the variance. So we take 1 sigma interval. So depending on the situation, you can take 2 sigma. So of course the randomness has quite a wide range, but we do not care about rare case. We only 1 sigma or 2 sigma depending on the situation. So as you understood, we take only 1 sigma interval to solve this one. Then the other side will neglect. Then we can build the fuzzy regression model for the fuzzy random data. So we build a model like the fuzzy randomly. We include y value by model. This is fuzzy random inclusion. So fuzzy random inclusion means we do not include the whole values, such as rare portion. Only the important portion will be considered of, say, 1 sigma or 2 sigmas. It can be written like this. We take the mean and 1 sigma. So we consider 1 sigma interval, center, and 1 sigma, right? So this interval will be considered. So this problem is the same, fuzzy problem, right? This is a fuzzy number, this is a fuzzy number. So we can solve this problem easily. So this problem is written like this. This is so fuzzy random inclusion can be translated like this. So this value is fuzzy interval, instead of probabilistic expression. So we can solve this problem as I told, fuzzy problem. But as I told you, if we have 1,000 feature, 1,000 variables, and 10,000 samples, this is not rare in economy problem. So the industrial problem is rather small. So this gives 2 times 10,000 times 2 powered 1,000, because we have to consider each vertical point. Vertical point is expressed at 2 powered 1,000. Is it clear? So the huge number of constraints should be considered to solve linear programming. Of course, linear programming is rather easy, but even though this size is quite huge, so we may employ the heuristic method. My heuristic method can solve the solution quite successfully. Almost all the result hit to the optimal solution. Of course, not perfectly, but we can obtain the solution, almost all the perfect solution, but some are near solution. So the heuristic strategy. I do not explain this one. So we may write this problem like this. So like this, right? 2k power to k. The constraint is the given. Then we return this problem. So of course, the same way, even linguistic variable can be solvable using this fuzzy problem. Then this was initially in 1984. Presented for the civil engineering problem. At that time, the Kim Sun-fu, the quite famous professor, he passed away just after 1 year after this paper, and James Yao is a professor of civil engineering. I skipped this one, and then this can be solved using dictionary and obtain numerical value. It is quite similar to fuzzy control. So we have like this numerical values. Sometimes it is given with a probability. So we can build this model. This is a fuzzy linear function, but we have to build how can I say, the relation. So this relation can be obtained by a output of this. So then we may translate the fuzzy number into linguistic word by like this. Like this. When we have this one value, then we check the dictionary. So we can find several words to hit with this fuzzy number. For example, the hit with bad with grade this one, hit with very bad with grade 1, and hit with extremely bad with grade 1. So we select the most appropriate word. That means the highest grade with the most appropriate word. In this case, we select the very bad for the fuzzy number obtained from fuzzy linear function. So we can solve such a problem easily. Then we apply tested the data like this. We give this one and obtain this value by the fuzzy linear function. Then we may translate this one to the linguistic word based on dictionary. It will be like this: assessed word, given word by expert. We check the 16 testing data. All the same, but it is not easy. Not always the same. So sometimes the different value will be given. But anyway, this method gives some possibility to obtain rules, linear relation rules for the fuzzy logic or the fuzzy natural logic. But Professor Novak did not give such a way. Another is rough set. I think I think a rough set is quite usable. We may employ it. Of course, Professor Novak will be how can I say, comment this portion. Like this, we can obtain some. This is the tested data. We can have the same. Then we apply this problem again. This is the real data. So we apply this one and apply this one. We obtain the value, and this is the model of numerical portion. So in this case, the color is quite important, quite large value, and fuzziness. And also I do not know remember detach or the attach and detach and the shape like this. So but anyway, color is quite important for the expert to select the good fruit. This is another paper for the fuzzy random data. I stopped this one. This is another problem. Anyway, thank you very much for your attention.